so that we finish up. Okay, the safety of using these lamps. We look at we realize that these lamps have rays. So that is why they are called the ultraviolet radiation lamps, because they are lights, or they are among types of fixtures that normally expose, they omit or they emit some ultraviolet rays. Uh, Now, something like I want to start with an example like the Xenon Arc Lamp. Xenon arc lamp is a specialized type of gas discharge lamp that produces light by passing electricity through ionized xenon gas at high pressure. So the lamp generates a bright white light that closely mimics natural sunlight. Xenon arc lamps are used in movie theater projections and searchlights, as well as the industry for research and to stimulate the sunlight. So these are the special kinds of lamps. And how do we use it? How do we use them safely? So the xenon arc lamps are structurally similar to short arc lamps, except that the arc containing portion of the glass tube is greatly elongated. So when mounted within an empirical reflector, these lamps are frequently used to simulate light. So typical uses include the solar cell testing, the solar simulation for edge testing of materials, rapid thermal processing, and material inspection. All xenon short arc lamps generate substantial ultraviolet radiation. So the xenon has strong it has strong spectral lines in the ultraviolet band, and these readily pass through the fused quartz lamp envelope. So the UV radiation release a short arc lamp that causes secondary problem of ozone generation. So you see, one of the problems that they bring about is they bring ozone. They bring about ozone layer. So the equipment uses a short arc lamp as the light source and must keep the ultraviolet radiation contained and prevent ozone buildup. So many lamps have a shortwave, the UV blocking coating on the envelope, and are sold as the ozone free. So lamps of this similar application, some lamps have envelopes made up of the ultra pure synthetic fused silica, which allows them to emit useful light into the UV region. So we are trying to take care of our environment, and we have said that most of these lamps they use uh, the the lights that emit dangerous gases. So we go to the halide, the metal halide arc lamps that we talked about. A metal halide lamp is an electric lamp that produces light via the electric arc through a gaseous mixture of vaporized mercury and metal halides compound on metals. So the most common metal halide compound used is sodium iodide. Once the arc tubes reaches its running temperature, the sodium dissociates from the iodine, which adds orange-red to the lamp, and the spectrum from the sodium D line is the metal ionizes. So as a result, the metal halide lamp produce an intense white light and have high luminous efficiency at approximately 75 to 100% lumens per hour. So which is about twice the mercury vapor lights and 5 times those of the incandescent lights. So the lamp life is 6,000 to 15 hours, and primarily developed for use in film and television lighting, which requires a high temporal stability and daylight color match. So the metal halide lamps are used for wide area overhead lighting for commercial, industrial, and public spaces, such as parking lots, sports arenas, factories, and retail stores, but also for residential security lighting. So most of the type of these are fitted on the outer glass bulb to protect the inner component to prevent heat loss. So that is one of the ways. So the outer bulb can be used to block some of the ultraviolet light generated by the mercury vapor discharge. So we said that we want to use this light safely. So that is how, or one of the ways of using it safely. So the metal halide lamps requires a warm-up period as long as 5 minutes depending on the lamp type. While it warms up, the lamp exhibits a different color as the various metal halide vaporizes in the arc chamber. So the mercury vapor lamp, how now do we use them safely? The mercury vapor lamp is a gas discharge lamp that produces light via the electric arc through vaporized mercury. So the arc discharge is generally confined to a small fused quartz arc tube mounted within the large borosilicate glass bulb. So in low pressure mercury vapor lamps, only the lines at 184 and usable synthetic quartz can be used in the manufacturing to keep the 184 millimeter light from being absorbed. So in medium or pressure mercury vapor lamps, the lines are from 200 to 600 millimeters are around are they are present. So the lamps can be constructed. You can see the lamps can be constructed to emit primarily the ultraviolet around 400 millimeters. So the ultraviolet lighting purposes. So they emit primarily in the blue, green. So some mercury vapor lamps, including metal halide lamps, must contain a feature that prevents ultraviolet radiation from escaping. So we say this ultraviolet radiation is the most dangerous thing or substance that is emitted by these lamps. So the basic thing in using these lamps safely is to make sure to protect them as much as possible so as to make sure that they don't emit these waves or this ultraviolet to the environment or to the surrounding. We also have the deuterium arc lamps. Also, the deuterium arc lamps are simply deuterium lamps in the low pressure gas discharge light source are often used in spectroscopy when a continuous spectrum or ultraviolet region is needed. This kind of lamp emits radiation extended from 102, 112 to 900 millimeter nanometer, although its continuous spectrum is only from, from only 180 to 370 millimeters. So the deuterium lamps are often used with the tungsten halogen lamps to allow measurement to be performed by both the ultraviolet and the visible regions. So other kinds of lamps that we have are the halogen lamps. Now halogen lamps, how do we now use the halogen lamps safely? Halogen lamps, also known as the tungsten halogen quartz or iodine lamp, is an incandescent light lamp that has a small amount of halogens such as iodine and bromine added. Like all incandescent light bulbs, the halogen lamps produce a continuous spectrum of light from near ultraviolet to deep into the infrared. So since the lamp filament can operate at a higher temperature than the non-halogen lamp, so the spectrum is shifted towards the blue, producing light with a higher effective color temperature and a higher power efficiency. So this makes the halogen lamps the only light source that produces black body radiation spectrum similar to that of the sun and more suitable for the eyes. So they are very advantageous because of the black substances they produce and they protect our eyes from what we say that is called glare. So high temperature filaments emit some energy in the ultraviolet region. So some amounts of other elements can be mixed with the quartz so that the doped quartz block harm ultraviolet radiation. Because the halogen lamp operates at very high temperatures, it can pose fire and burn hazards. Now, to reduce the unintentional ultraviolet exposure and to contain hot bulb fragments in the event of explosion or bulb failure, a general purpose lamps usually they use the ultraviolet absorbing gas filter. So you see they have a gas filter to be able to absorb the ultraviolet rays. Now what about the fluorescent lamps? The fluorescent lamps are used for the UV curing in a number of applications. In particular, these are used when the extensive heat of mercury vapor is undesirable or when item needed for more than single source of light and instead of the item needs to be surrounded by light. So such musical instruments, fluorescent lamps are produced. They produced ultraviolet where anywhere within the ultraviolet to A stroke AV B spectrum and it can be created. You remember we talked about the spectrum and where the ultraviolet rays can be emitted. And we have the limit, the light emitting diodes, the LEDs, when have recently been used in research laboratories to construct solar simulators. They offer a promise in the future of energy efficient production of spectrally tailored artificial sunlight. So the LEDs are the ones that are mostly like these days because they have a very good uh, substances that are able to emit productive light. So threshold limit values, the most hazardous ultraviolet rays emitted by the UV lamps is that with the wavelengths between 240 to 315. So in this range, the threshold limit value, that is the TLV, is less than 10 millijoules per square centimeter, and the most restrictive threshold limit uh, value is the UV is C, that is 270 millimeters, which is the set by 3 millijoules per square centimeter. So we also have hazard risks from the UV lamps. So the UV lamps, so we have talked about all these we have talked about are the lamps that are able to emit the ultraviolet rays. So the UV lamp produce light radiation from the ultraviolet through the visible infrared radiation. So the biggest hazard comes from the UVR, that is the UVR cannot be seen and is not felt immediately. So but it is harmful to both eyes and the skin. So the user may not utilize the danger until after the exposure has caused damage. The symptoms can occur 4 to 24 hours after exposure. So the effects on skin are on of two types, that is acute and chronic. Acute effects appear within a few hours of exposure, while chronic effects are long lasting and cumulative and may not appear for years. An acute effect of the UVR redness of the skin caused and the erythema, that is the similar to sunburn. That is now the risks, the hazards of these lamps. So the chronic effects include accelerated skin aging and skin cancer. So the UV radiation is absorbed in the outer layers of the eye, the corona, and the conjunctiva. Acute overexposure also leads to painful temporary inflammation. So mainly the cornea, known as the photokeratins. Repeat exposure of the UV is unlikely because of the pain involved. So chronic exposure leads to an increased risk of different types. So working unprotected, or even few minutes can cause injury. So it is possible to calculate the acute threshold for acute effects of the set exposure limits. So other hazards related to the use of the UV lamps. So what are these other hazards? So all the lamps are used with solar stimulators, contain high pressure gas and may explode if not handled properly. So avoid touching or scratching the glass section of the lamp. Fingerprints should be wiped off with the isopropyl alcohol. So those are some of the things that should be done to protect both the eyes and the skin. We protect ourselves from things like mercury. So some of the solar stimulators, such as mercury-based arc lamps, mercury contamination can occur in the lamp breaks and explodes. So consult with the industrial hygienist on proper handling of the mercury-contained lamps. And ozone. Ozone is the short-wave wavelength converts oxygen into ozone, and the ozone produced by the lamp with high UV output can be a major irritant to the user. So even the ozone-free lamps can produce enough ozone to be uncomfortable uh, or someone who is practically sensitive, a proper ventilation should be considered before the system is in use. So we have electrical shock is some of the other things that can be caused by these lamps. During the normal operation, the user is protected from contact with an energized electrical connections. However, electrical shock danger will occur if interlocks are defeated for the power supply since it is opened, but it but opened with the unit still plugged in. So unplug the unit before replacing the lamp or serving the power supply section. And then the heat. An arc lamp envelope reaches very high temperatures during the normal operation and can cause severe burns if touched. So let the lamp cool at least 15 minutes before opening the lamp. So the control, there are three types of control measures. We have the engineering measures, the administrative, and which are also the procedural and the personal protective equipment. So what are the engineering controls? Location, meaning having the UV generation devices located in separate room, that is, and low traffic area of a lab is ideal. So to avoid exposure to other personnel, avoid placing the UV generating devices in the vicinity of the desk areas or other equipment. Enclosure also. The use of light tight cabinets and enclosures is the preferred means of preventing exposure. Where it is not practicable to fully enclose the UV sources, we use screens, shields, and barriers. Interlocks. These are also for locking to avoid electrocutions. So in solar stimulator enclosures, come with interlocks. Alternatively, the interlock devices can be installed. Interlocks should not be tampered with and should be replaced or repaired when defective. Now, the typical administrative controls include limiting access, ensuring that people are aware of the potential hazards, and providing training and safe working instruction for users. So the personnel should be trained in using the UV generating devices safely. So the manufacturer's manual provides specific safety related information and unnecessary or unconcerned existing regarding the safe use of the UV generating device, contact and manufacturer of clarification. So you can see these are some of the protective things that we use. And there's also minimizing of the exposure. There's hazard warning signs. You use these signs to warn that there are dangerous things here. We also use protective equipment, that is the PPEs, which are the eyewears, the face shield. Now, like for example, like for the arc welding, to protect our eyes. And then we also use gloves, we also use lab coats and neck gaiters so that we can be able to protect the people using these documents or these substances. So takeaways, safety tips. Number one is always use appropriate PPE for the hazard face shield, UV face shield, goggles, gloves, button up lab coat. And then enclose the light generated by the lamp at the extent possible. Avoid touching or scratching the glass section of the lamp. Fingerprints weaken the lamp envelope. Do not touch the lamp while working. Let the lamp cool at least 15 minutes before opening the lamp. Use proper ventilation with the lamp that are not ozone free. Then another thing is, do not use the lamp near paper, cloth, or other combustible materials because they can cause fire. Do not overcool the lamp. Air should never be directly forced on the bulb because it will result in uneven cooling. That is, recommended cooling methods are airflow, nitrogen gas flow, and the use of heat sinks. Always keep the lamp in the provided a protective case or cover until installation, and then save the protective case or cover the packing materials or box for lamps that have been used to their rated service life. Use the protective case when disposing of the lamps. Firmly attach tape around the original cardboard box to seal the lamp securely. So the Xenon Arc Lamp should not be used beyond their rated service life. Operation beyond the rated service life may cause the lamp to burst. So those are the safety precautions that we were talking about that are very important when using these lamps. So, for today, I'm done with the slide that I was about to offer, and I told you that we have finished the syllabus and we will start the revision. So, we will start revising, and I would like to hear questions from you. Before we wind up today, let me hear you ask questions of what we have studied the whole of the semester, and even what you studied with the other lecturer when I was not there. So you can unmute your mics and talk to me. Unmute your mics. Unmute your mics. Yes, Humphrey, say something.
Okay. According to today's class, it was very educative and kulingana na nini, the other teacher umekuwa kutufunza vizuri sana.
Lakini mmeelewa vizuri?
Tumeelewa, tumeenjoy sana kwanza.
So, unajua tumemaliza syllabus, Humphrey, tumemaliza syllabus ya EMFD. Si ninajua kuna vitu zingine zenye labda mmesahau.
Hizo tutapitia.
Sasa ninataka from next week.
Yes.
Salad.
Yes.
What we'll be doing next week ni tutaangalia, si unaona tuko na notes zote za all the units tumesoma, all the topics tumesoma. So next week kama sitaenda leave because I might go for leave. Kama sitaenda leave tutafanya review. Tutaangalia topic moja tunapitia so that hiyo wiki inafuata ndio sasa tutaanza kufanya hizo past papers. Nitakuwa nawapea past papers mapema, watu wanatafuta majibu, tukikuja kukutana ni kudiscuss. I want us to make sure that we pass these units. Japo ni sawa.
Hata online kuna leave.
Wanaenda kupumzika.
Si ndio Salad? Kwani hizi ni kazi tunafanya?
By the way, madam. Yes, madam, by the way. Unaona hata tukifanya election ya lecturers gani nzuri. Online. Ningeweka wewe. Ningechoose wewe.
Oh, kwani wengine wanafunza aje?
Yako ndo best. Lazima
lakini mnaelewa. Unajua kitu muhimu ni nyinyi kuelewa.
Tunaelewa. Hata ukitupea assignment at least unatupeanga time.
Assignment tunatuwekea siku kama 2, 3 ama 7 days. Unajua wengine wanatuwekea 30 ama 1 hour.
Sasa 30 minutes utatafuta aje mpaka upate uweke?
Sasa wanatutimia maswali kama 16 30 minutes.
Kulima ametuwekea 18 na ni calculation.
Na sasa uta calculate saa ngapi?
Una calculate na attach. Vitu mingi sana.
Lakini sasa nimerealize hiyo ku attach it takes a lot of time.
Yes.
You know, I tried to do that. Sidi kuna hiyo hesabu nimewafanyia. So I wanted to attach. Nikaona inasumbua sana. So it takes a lot of time. Lazima mtu uchukue muda mwingi. Sawa sawa. I will consider that in cut 2 and at least give you some time. Naweza nikawapea hata 2 hours ama 1 hour. Si 1 hour ni sawa?
Why now ni sawa.
Kuliko ile ilikuwa
Alafu
40 minutes.
Alafu nimeattach kwa hii group discussion ya leo. Nimeattach swali lingine ya photo.
Sawa, tukimaliza tunaingia kwa discussion tuangalie. Na huwa ninapenda kwanza wanafunzi wakijibu maswali kabla niongee. Unajua it is test if you guys are understanding. I want to see if you are really understanding. Ni vizuri nione maswali zenu wakina Humphrey. Make sure you participate before mwalimu aangalie. Si ati unaniambia nimeona lakini sijaangalia, sasa hiyo ni nini?
Nimeelewa, sikuwa nimechaja hata simu.
Sawa sawa. Alafu wakina Edgar wanapotea na network kama ni nini iko shida kwao?
Sasa kuna wengine hawajalipa fee.
So school fees ndio inafanya watu hawaingii.
Sasa hawezi access.
Watu wamefungiwa. Anyway, msijali, face to face itarudi tu.
Wanasema ni September.
Lakini najua nyinyi mko likely kufanya mtihani yenu hata March. Si nyinyi mlikuwa mmefanya July? Ama mlikuwa mmefanya lini? November. So inamaanisha mtasoma September to December tufanye na project. Alafu January to March mfanye mtihani. Si hiyo itakuwa sawa na nyinyi? Lakini mtakuwa mmesoma already ni moja. Access.
Ndio.
Si mtakuwa mmesoma access moja ama mfanye mtihani December. Itakuwa haraka sana hiyo.
December pia ni sawa.
Lakini kwa wale watafanya ni wale waliregister mtihani. So unajua hawakufanya mtihani. Nyinyi mlikuwa mmeregister?
Bado.
Sasa si mkirudi sasa ni kama ndio mnaregister. So you guys, I'm wishing you the best and I want you to work very hard. Hiyo group yenu wewe inanifurahishanga sana. You are hard working class. Na mnafanya kazi kwa bidii. So muendelee hizo na mpite muingie module 2. DE. Si ndio?
Yes.
Sawa. So nataka tuende sasa kwa discussion tuone hizo maswali za salad. But prepare yourself. Next week tutakuwa tunafanya a review of everything kenye tumesoma. Tutakuwa tunapitia kila topic, tunajikumbusha before we can start revising now. Is that okay?
Yeah.
Yes.
Sawa. Kama hamna maswali, si tuende kwa discussion.
Sawa.